lesson, we're going to give you a function, and we want you to go through what I call my four-step process to find the inverse of that function. So I do want you to write down these 4 steps. Number 1, you're going to replace the function notation with the letter y, so you're changing it to a relation. Number 2, this should look familiar to you. You're going to interchange every x and every y by interchanging them, flipping them around. Step 3, you're going to solve this equation for y. Step 4, we're going to replace the y with f inverse notation, identifying that it is the inverse function. Now, not every inverse will be a function, and we'll get more into that in a separate video. All right, let's go ahead and do this 4-step process. So I have the steps to the left here. We'll go through them together. So here is a function f of x equals 4x minus 5. It's actually considered a line, a linear function. So our linear function would pass the vertical line test if we imagine graphing it out. It has a slope of 4 and a y-intercept of -5. All right, so let's go ahead and do step 1. Remember, step 1 is to replace the function notation with the letter y. That is converting it back to just what we call a relation. Step 2 is to interchange the x and the y in the equation. So now this becomes an x, and that becomes a y. Step 3 will always be your longest step. We want to solve this equation for y. So we have to do what we call undoing. Your textbook uses the word finding inverses by undoing. So the first thing we have to do is we have to undo that -5. So we're going to go ahead and add 5 to both sides. That is going to undo the -5 on the right-hand side, so those will cancel out. So now we have x plus 5 equals 4y. Now we need to get rid of the 4, so we have to undo the 4. So to undo the 4, we're going to divide both sides by 4. So we have a 4 here, and then a 4 there. The 4 and the 4 will cancel on the left, or on the right-hand side. And then we have x plus 5 over 4. The last step is to replace the y with the f inverse function. So we say f inverse equals x plus 5 over 4. Now, what I'm going to do is I'm going to separate out this function's fraction into 2 separate fractions, just so it's a little easier for us to graph in just a moment. So we have 1/4 x plus 5/4. Not the easiest function to graph because the y-intercept is 5/4. So we're going to do our best try on it. So let's go to the next slide. All right. So continuing with that example, our original function was our linear function, 4x minus 5. So I'm going to write that in red without function notation. And then my inverse function, y equals 1/4 x minus 5/4. So this is green is what I just found on the last slide. Again, where I got this from, it's right down on the bottom. 1/4 x plus 5/4. All right. Now, in a previous video, we did show you a set of ordered pairs and we connected those points. And then we graphed this line, y equals x. And we showed that those 2 lines are symmetric about the inverse line, y equals x. So we're going to graph that in a little bit. But let's first graph these 2 functions, the red and the green. So the red one's pretty easy. It's just going down 5 units on the y-axis. That's our y-intercept. And then we're going to rise 4 and run 1, because that's our slope. So we're going to count up 4 and then run 1. I'll do another one. So we'll rise up 4 and run 1. Okay, let's do another one. Okay. So there is our graph of our line. Notice it does pass the vertical line test. It is a function. The green one, a little bit more work. This is your y-intercept, and that is your slope. I'm going to have to do my best job. Or I can interchange my ordered pairs. That would be the other way. So let's talk about that. So one way would be to kind of estimate -5/4, which is about down here, and then rise 1 and run 1. Or, if you remember, I can interchange each of these ordered pairs. So here's that first ordered pair, over 0, down 5. This one is over 1, down 1. This one is over 2, up 3. And this one is over 3, up 7. In order for us to come up with our new ordered pairs without having to go through and graphing the slope and y-intercept, we can just interchange them. So this point, interchanged, would be 7, 3. This one here would be 2, 3. This one here, oops, 3, 2. The next one, -1, 1. And then this one here, -5, 0. So it gives us some nicer points than doing that approximation of the slope and y-intercept. So we'll graph those. I'm just going to erase these green arrows. I'm going to show you where I was getting them from. So we're going to go over 7, up 3. So that's the inverse of that top point. The next one is over 3, up 2. The next one is -1, up 1. And then -5, up 0. So now here is our new inverse function in the green. All right. Now, we're going to graph that line y equals x and show that these two are symmetric about that line. So y equals x, the y-intercept is 0, and the slope is 1. So let's graph that. Y-intercept of 0, slope of 1. You imagine folding the coordinate plane along that blue dotted line. The green and the red lines should smash right onto each other.